Hello, my name is Jenna Rowan and we are Dragon Shield. Wildfires are causing an alarming amount of damage in fire-prone areas. In 2018, 25,000 structures burnt down, including over 18,000 residences and 200 commercial buildings. In the Paradise Fire alone in November 2018, 11,000 homes burnt down and only 11 homes have been rebuilt since. Insurance companies are raising their premiums or refusing to insure homes in fire-prone areas. This affects homeowners and real estate agents alike. It is hard for a homeowner to afford the high premiums as they've increased 2 to 3 times, and this is also a deterrence to those looking to buy a home in a fire-prone area. Western Reserve University did a study on the usefulness of a fire blanket being used on a house to protect in a wildfire and found that it was capable of protecting a house from most damage. Here is a picture of the wooden panel they used to test their hypothesis in the first experiment. Now I will hand it off to Chris, who will go over the problem statement.
Thank you, Jenna. Thousands of people lose their homes each year because of wildfires. The only thing homeowners can do in the event of a fast approaching fire is to hope that firefighters will get there in time. People need an additional line of defense to protect their homes and possessions. Wildland firefighters use fire-resistant material to protect small structures. However, there is no way to deploy the material over residential houses quickly and efficiently. Now I'll be handing it off to Ryan, who will be discussing the design.
Thank you, Chris, and hello. My name is Ryan Vukasin, and I will be discussing the fully fledged Dragon Shield design today. The base of our design is an accordion-folded fire blanket curtain that is composed of a vermiculite-coated fiberglass fabric. The curtain includes a magnet at the bottom, which will help the gravitational deployment, as well as attached to a steel plate at the bottom of the house for security. The Alnico magnet was selected due to its heat resistance and pull force specifications meeting our demands. The curtain will be contained within an 8-inch wide housing comprised primarily of 6061 aluminum. This material was chosen due to its lightweight and corrosive resistant properties, as well as being within our budget. The housing is a simple trapdoor design that will be opened via the release of an electric latch that is actuated through a 12-volt electric pulse. Overall, this design will serve as a good proof of concept for our capstone project, coming in just under the $1,000 budget. I will now pass it to Merrick, who will explain the proof of concept test plan for Dragon Shield.
Thank you, Ryan. My name is Merrick, and I will be going over 4 key product design specifications with our test plans, failure criteria, and revision plans. One key spec is PDS 3.4, which states that our product must be mounted evenly to distribute the weight to less than 10 pounds per square foot. To test this, we plan on weighing our test housing with all the components inside and dividing that by its length to give us an accurate pounds per square foot measurement. This spec would fail if the pounds per square foot exceeds 10 pounds. Our revision plan would be to use lighter components or housing made from a thinner aluminum sheet. Another key spec, PDS 4.2, requires our product to deploy in less than 5 minutes. For this test, we will use a stopwatch to measure the time it takes from the user activation to full deployment. This spec fails if our product takes longer than 5 minutes to fully deploy, which would force us to implement motors into our housing that would feed the protective material out quicker. PDS 5.2 requires that our electronic components must be able to properly deploy the material for temperatures from 30 degrees to 150 degrees Fahrenheit. To test this requirement, we will attempt the deployment of the system under these conditions. To test the colder temperatures, we will attempt the deployment outside when temperatures drop to 30 degrees, and to test the higher temperatures, we will use heat guns to warm up the system and then attempt deployment. If the material cannot be properly deployed for temperatures 30 to 150 degrees, then the revision plan is to better insulate the electrical and mechanical components by surrounding them in their own separate housings. Lastly, PDS 5.4 requires our product to be water resistant to prevent water or snow from damaging the material inside during non-use times. To test our product's water resistance, we will submerge the housing underwater. If any water is inside the housing once we pull it out, the specification fails. Our revision plan in case of a failure is to use a sealant on all edges and openings to better enclose the housing. Now on to Dean, who will be discussing our manufacturing plan.
Thank you, Merrick. For Team 5's Dragon Shield deployment system, the following Gantt chart will be used to lay out the manufacturing plan. First, the priority in manufacturing the deployment prototype is fabricating and modifying all custom pieces for all assemblies and ensuring delivery of all other BOM items. This includes drilling pilot holes in the housing, fabricating the door panels, modifying all hinges to length, and inspecting all items for spec conformance. Second, the code for all electrical controllers needs to be started in anticipation of errors. Once all materials and items for each subassembly have been collected, production for each subassembly may begin. Since the fire protective material has the longest lead time, the material subassembly will be built last. Finally, once all subassemblies are correctly produced, they will be combined into the final prototype. Possible challenges include folding interference with proper setup or deployment of the material, weatherproofing gaps or clearances, electrical failures or shorts, coding errors, and or non-conformance tolerance parts. More or less challenges may occur. If any challenges listed arise, possible solutions are listed. For folding difficulties, origami practices should be used to conserve space between folds. For weatherproofing gaps, extra gaskets or foam tape may be used. In the case of electrical malfunctions, the wiring should be checked against a schematic and or a multimeter should be used to diagnose issues. Coding errors should be solved using compiler notes and or school and faculty resources. If fabricated parts are out of tolerance, adjustments to adapt parts should be implemented. If no adjustments can be made to account for the nonconformance, a new part may be fabricated. Thank you.